Hello everyone, let's continue the last part of the resistivity. So we talked about getting the data based on the resistivity experiments. You remember we did this example in the previous video, and these data were coming from the core samples, and with that you can get the saturation exponent found from the experimental measurements. But if you want to really find the water saturation inside your reservoir, you want to run some logging tools into the wellbore. So if you do that, you basically send these logging tools and they measure the resistivity of the an area around the wellbore. So depending on what type of resistivity log you use, you measure the resistivity of your reservoir at different basically depths into the formation, so depending on what type of resistivity log you use. Now drilling would change the resistivity of the formation close to the wellbore due to invasion of the drilling fluid or mud into the formation. So if you look at this picture on the right hand side of this slide, you can see that the mud will invade your formation, form a mud cake close to the wellbore, which is basically a thin or thick layer of drilling fluid solids formed around the wellbore, and then the base fluid of your mud will invade the formation. Now you might have oil-based mud, which the main fluid of your drilling fluid is oil. In that case, since it's oil have low conductivity, so it will change the conductivity of the formation close to the wellbore. It drops the conductivity because it's oil which invaded your formation. Now usually oil-based mud have a shallow invasion, so it doesn't go too far and it has a thin cake. Now if you have water-based mud, you have moderate to very conductive mud because it's water-based, usually have some salt and it's conductive. And water-based mud could invade your formation to higher depths, from shallow to deep invasion depths, and it's a thin to thick cake. Okay, so if you look at this picture on this slide, you can see that this is a top view of your wellbore, and drilling mud is inside, and then there is a mud cake formed around your wellbore, which if you send the logging tools into the wellbore and measure the resistivity of the vicinity of your wellbore, the resistivity that you measure is basically mud cake resistivity, and we show it with RMC. And then close to after that we have a layer of invaded zone, depending on if you use the oil-based mud or you use the water-based mud. This layer could be shallow or deep, and we call this invaded zone resistivity RXO. And after that we have we have a transition zone, of course, which basically you have both a mixture of your formation fluid and the drilling fluid, and then at very deep locations you have uninvaded zone, and that uninvaded zone is actually what you record as RT. So RT, or true resistivity, is the resistivity of uninvaded zone. Now assume that you have RT. How do you use it to calculate the saturation of water inside your formation? Yes, we did that example to calculate the saturation exponent, right? So if you have the saturation exponent and you know what type of model you want to use for your what is your cementation factor, what is your A constant here in this equation, and if you know these parameters and you have the brine resistivity of your formation, then you can and you have the value of your RT, then in that case you have every information to calculate the water saturation. So my point is that you get N from experimental measurements you can also get A and M from experimental measurements of the core samples of the same reservoir. So these empirical values comes from the experiments, experiment, and then you have RT from log, and then you put it into this equation, you get SW of your formation. So this is how basically it works, right? So you get the data, some empirical constants from experimental measurements in the laboratory, and then you run logging tools to get the RT of your formation, and then based on that you can calculate the saturation of your reservoir. But you should be careful where to select your true resistivity, because you have to select the values in the range that are uninvaded zone, right? So this area, you can read the resistivity of this area to be your RT. You'll get some more information about RXO, RMC in the formation evaluation course, and you will deal with the calculations related to those values. We are not going into the details of that in these videos. And I think this is the last video for resistivity, and we'll continue on the new topic next week.